In the previous two videos, we looked at a population shown here, a population of errors in medical records, with this standard deviation for the population and a distribution heavily skewed to the right. Then we took 250 samples from that population, samples of size 30. This represents the mean of the first sample, the mean of the second, and so on. And that set of means, or the mean of all means, was very close to the mean of the population, and the mean of all means had this standard deviation. The distribution of those means looked like this. Now the question arises, is there any relationship between this standard deviation, that is the standard deviation of the mean values, the standard deviation of this distribution, and this standard deviation here, the standard deviation of this distribution, or the actual data? The answer to that is yes. The standard deviation of the mean values, which is called the standard error of the mean, is equal to the standard deviation of the population data divided by the square root of the sample size. And in our case, we took samples of size 30. So the standard deviation for the sample means, what is called the standard error for this data set with samples of size 30, is 0.21. Now let's look back at the sample, and we see that the standard deviation of the mean values, the standard deviation of this distribution, is 0.22. And that is what is called the standard error. Why is this value not exactly the same as this value? It's because when we took 250 samples of size 30, we only got a small proportion of all possible samples of size 30 that we could take from these data. The actual number of samples would be equal to 600 raised to the 30th power if we were sampling with replacement, which we are. That number is very large. So if we possibly could take all these 2.2 e to the plus 83 samples, the standard deviation of the means for all those samples would be exactly equal to the population standard deviation.